All right, so I'm going to go over the two problems from section 3.4 that I assigned yesterday. All right, so so the first thing you have to do is we have to find the derivative. All right, these are nice polynomials, so the derivative is just 3x squared minus 6x. All right, once you find the derivative, you have to find the critical values, which means you set this equal to 0. So in order, now I set this equal to 0. Take out a 3x, and I get x minus 2. So set that equals 0, set that equals 0. So my two critical values are going to be 0 and 2. That's what I put on my little number line. All right. So now, first thing you do is increasing and decreasing, and you figure out the maximum. This all has to do with the first derivative. The stuff we talked about yesterday, the concavity, has to do with the second derivative. We're not there yet. So we are going to plug into the derivative right here. So I plug a number less than 0. If I plug in -1, 3 times -1 is a negative. -1 minus 2 is a negative. Negative times a negative is a positive. So I get a positive number, which means any time the derivative is positive, that means the original is going to be increasing. So then I plug in between 0 and 1. Plug in 1. 3 times 1, that's a positive. 1 minus 2 is a negative. Positive times a negative is a negative. That means between 0 and 2, since the derivative is negative, the original is going to be decreasing. All right, anything larger than 2, like 3. 3 times 3 is positive 9. 3 minus 2 is a positive 1. Positive times a positive is a positive. So that means it is increasing wherever I see a positive on here, that the original is increasing wherever the derivative is positive. So from negative infinity to 0, union 2 to infinity. It is decreasing wherever it's negative, and that's between 0 and 2. All right, max and mins occur wherever there's a change from increasing to decreasing, from decreasing to increasing. So it happens plus to minus. So it's going increasing to decreasing. Well, what does that look like? That looks like a max. So I have a max at 0. Here is decreasing and increasing, which means I have a min at 2. To find the y values, you have to plug into the original. So if I plug in 0, 0 minus 0 plus 1, 1. Plug in 2. 2 cubed is 8. 2 squared is 4. 4 times 3 is minus 12 plus 1. 8 plus 1 is 9. 9 minus 12, negative 3. So I have relative max at 0, 1, and a relative min at 2, negative 3. All right, so that's what we had done before. What we learned yesterday is we can do the second derivative, and that will tell us where it's concave up or concave down. Concave up is things that have curves that either look like this or like that. All right. Concave down means either curves that looks like this or like that. All right. So it's like the two parts of a parabola pointing up are concave up. The two parts of a parabola that point down are concave down. That's what they look. And we'll worry more about drawing them later. But then I do the second derivative. The second derivative is the derivative of the first derivative. So that's 6x minus 6. I set that equal to 0. And I just get x equals 1. So I only have one critical value here. So I just have to plug in something less than 1 and greater than 1. And we're plugging it into the second derivative. Wherever the second derivative is positive, that's where it's concave up. Where the second derivative is negative, it's concave down. So if I plug in 0, I get 0 minus 6, which is a negative. If I plug in a 2, I get 6 times 2 is 12. 12 minus 6 is 6. That is a positive. So that means it's concave up. From 1 to infinity is concave down. From negative infinity to 1. All right. So now points of inflection are any place where it changes concavity, meaning anywhere you see it go from negative to positive or positive to negative. All right, so basically this is going from concave down to concave up. That's a point of inflection. So we have a point of inflection at 1. And just like with the max and mins, to find the y coordinate, you plug into the original. So I plug in 1. 1 cubed is 1. 1 squared is 1. 1 times negative 3 is negative 3 plus 1, which it gives me negative 1. All right, so that gives me all of this information we found by finding the first and second derivative. All right. So for this one, all right, now for these, I will, on a quiz, I will give you what the derivatives should be. All right, so the derivatives are, the first derivative is x squared minus 1 over x squared, and the second derivative ends up being 2 over x cubed. All right, and I think just having those, that's going to eliminate some stress of, if you don't have the right derivatives, you can't get anything else right. And the point of this is not to know how to find derivatives. You guys have already done that before. All right. Point is how to, apply what the derivatives tell you. All right. So once you have the derivatives, all right. So in a case like this, you got to set the top equal to 0 and the bottom equal to 0, because that's where you have your critical value. So when you set the top, you get x squared equals 1, which is plus or minus 1. So plus or minus 1. And you also have 0 when you set the bottom equal to 0. So I have 0, negative 1, positive 1. Now, when you have a fraction like this, you have to be careful. There is a vertical asymptote in the original function at x equals 0. So at this critical value, you have to realize that there's an asymptote in the original, because at an asymptote, all right, it breaks things up. All right, you can't have points on there. You can't have, you might have, if it's positive or net, for increasing and decreasing, you have to split up the intervals. So you just need to know that's asymptote. I like to draw it right in there. All right, so then I plug in each of these things back into the derivative. So negative 2. So notice everything here is going to be positive. Does not matter what I plug in. All right, so it's always going to be a positive on the bottom. So you just got to plug into the top. Negative 2 squared is 4. 4 minus 1 is a positive. So positive over positive is a positive. When I plug in negative 1/2, negative 1/2 squared is 1/4. 1/4 minus 1 is a negative. A negative over positive is a negative. So the same thing happens when I plug in positive 1/2. You get a negative, and then this would be a positive. So it's positive, negative, negative, positive. So it's increasing wherever you have the first derivative positive. So that's from negative infinity to negative 1, union 1 to infinity. It is decreasing where there's a negative. Now, normally we would just say from negative 1 to 1, but there's an asymptote here. So you have to break that up because nothing is happening at an asymptote. So it's two separate intervals. So it's negative 1 to 0, union 0 to 1. If that was not an asymptote, then it would just be negative 1 to 1. But since it is, you have to put the union there. All right. So now for max or mins, where does it change? All right. So from plus to minus, it changes here and it changes here. All right. Now, if it had changed in the middle, you would not list that point because there's an asymptote there. All right, now it goes from increasing to decreasing, so that is a max at negative 1. It goes from decreasing to increasing, so that's a min at 1. And then to get those y values, you plug back into the original. Negative 1 squared is 1, 1 plus 1 is 2, 2 over negative 1 is negative 2. When I plug in 1, 1 squared is 1, 1 plus 1 is 2, 2 over 1 is positive 2. So we have a relative max at negative 1, negative 2, a relative min at 1, comma 2. All right, so then you would take the derivative of this, but I'm giving it to you. And now you just have the top and bottom equal 0. Well, 2 does never equal 0. But when you set the bottom equal to 0, you get 0. So there's only one critical value. And 0, remember, is an asymptote. So I have a vertical asymptote going through at 0. All right. So I plug in a negative 1 into the derivative. 2 over negative 1 is a negative. If I plug a positive 1, I get a positive. So anywhere where the second derivative is positive is where it's concave up from 0 to infinity. It is concave down wherever the second derivative is negative, from negative infinity to 0. All right, now it changes at 0, right, from negative to positive. However, that is an asymptote. You can't have any points on an asymptote, so there is no points of inflection. All right, and make sure you put like a slash through it, write none, whatever it is. Don't just write blank, because then I just won't think you know the answer. All right, so hopefully this helps answer some questions you might have. I'll clear up other questions on, like, especially like stuff with the theorems and stuff in class. And we'll spend a day or two in class reviewing before you're going to take any sort of assessment on this. All right. I hope you guys are staying safe, and I will talk to you soon.